Hi guys, this is Miss Scott. In this lesson, you guys are going to learn how to solve right triangles, which means finding the measure of every single angle and finding the length of every single side. So in this first example here, we're just going to talk about how you can find unknown angle measures if you know two sides. So in this table here, in every single one of these problems, we are going to find the measure of angle J. So, and it really depends on what sides you're given, what trig ratio you can use. All right, so when we have this situation where suppose we're finding the measure of this angle J, and notice that we have the side opposite and the hypotenuse in this right triangle. So we know from previous lessons that the sine of J is the length of the opposite over the length of the hypotenuse. And now if we want to get J by itself, here's the new part. What you can do to get J by itself is actually take the sine inverse of that left side. But remember in mathematics, if you do something on the left side, you have to do the same thing on the right side. So we have to take the sine inverse on the other side here. And what happens here is that this sine inverse and this sine cancel out and you're left with just angle J equals the sine inverse of 24/40. Now, if you look on your calculator does have inverse sine functions on it. So how you would plug this into a calculator, you would push your second button, and then above sine is sine inverse, and then in those parentheses you would just enter 24 divided by 40. So I would really recommend that you try that. If you do, you should end up getting 36.9 degrees. So why don't you pause the video, try plugging that in and see if you get that same measure for angle J. All right, let's look at another example here. So again, we're still looking for the measure of angle J. And now I notice I actually have the side adjacent or touching angle J, and I know the length of the hypotenuse. So if you recall, adjacent and hypotenuse, that means we have to use the cosine. So the cosine of angle J, remember, is equal to the adjacent, which in this case is 32, over the hypotenuse. Okay, and just like previously, to get J by itself, we have to get rid of that cosine function. And to do that, we're going to take the cosine inverse. And we're going to have to do that on both sides here. So we'll take the cosine inverse of the left and the right. Then the cosine cancels with the cosine inverse. And we are left with J equals the cosine inverse of 32 over 40. Okay, so again, go ahead and try and plug that in the calculator. The cosine inverse button is right above the cosine button. If you do that correctly, you should still get 36.9 degrees. Okay, angle J hasn't changed. This is the same triangle throughout all three of these examples. All right, and lastly, if we look here again, we're going to find the cosine, or the measure of angle J. Notice this 24 is opposite angle J, and the 32 is adjacent. So if you remember, that would mean we have to use the tangent function. The tangent of angle J is the side opposite over the side adjacent. And now again, I want to get J by itself, so I have to undo taking the tangent, which is taking the tangent inverse. Okay, so if we apply that to both sides, again, this tangent inverse and tangent cancel out, and we're left with angle J is going to be the inverse tangent of 24/32. All right, and again, if you go ahead and plug that into a calculator, which I, again, recommend that you give that a try, you should still be ending up with that 36.9 degrees. All right, so now let's look at an example where we don't know exactly which of those three trig ratios to use. Okay, so in each of these, we've got three triangles here, but in each one, we're going to find the measure of angle A. So for this first one, if I draw an arc on angle A, I notice that I have the side opposite and I have the side adjacent to that angle. Okay, I don't know what the hypotenuse's length is. So whenever you don't know the hypotenuse, that tells you to use tangent. So the tangent of angle A is equal to the opposite over the adjacent. And now to get A by itself, we've got to take the inverse tangent. And if I do that on the left, I better do that on the right. So this tangent inverse and tangent cancel out, and we will be left with A is going to equal the inverse tangent of 30/20. Okay, go ahead and plug that in a calculator, and you should find that the measure of angle A is 56.3 degrees. Okay. All right. In the next example, we're still going to be finding the measure of angle A, but now we've got new sides here, so let's see how they're related to A. I notice that this 9 is adjacent, and now I know 22 is the hypotenuse. So if you have adjacent and a hypotenuse, that tells you to use cosine. So the cosine of angle A is the adjacent over the hypotenuse. And now to figure out the measure of that angle, what are we going to do on both sides? Well, we're going to take the inverse cosine. And that's going to cancel out. And we'll be left with the angle of A is going to be whatever the cosine inverse of 9/22 is. So if you plug cosine inverse of 9 divided by 22 into a calculator, you should end up with 65.9 degrees. All right, so there we go. And lastly, probably need to look at an example of using sine, but let's make sure. So we're looking at angle A again. This 14 across from angle A is opposite that angle. And 26, notice, is the hypotenuse. So if you have opposite and hypotenuse, that means you're going to use sine. So sine of that angle A is the length of the opposite divided by the length of the hypotenuse. Okay, so now again, to get A by itself, we have to take sine inverse. If I do that on the left, I need to do that on the right. So these will cancel, and we'll be left with angle A is the inverse sine of 14/26. And if you plug that into your calculator using that inverse sine button, remember push second sine to do that, you'll get 32.6 degrees. All right, so there's how you can find missing angles. We haven't really gotten into solving right triangles though. So that's where we're going in this next example. To solve a right triangle, you have to find all of the missing side lengths and all of the missing angle measures. So what I like to do is just make a list of everything that I don't know in this triangle, so the missing info. I notice that I don't know the length of NM, so that's something I'm going to need to find. I don't know the measure of angle N, so that's another piece of missing information. And I don't know the measure of angle M. So I have to find three things, and typically when you're solving a right triangle, it's always going to be three things that you're missing. Okay, so let's just make a list of the things we need to know. And then we're going to solve for those things we are trying to find. When you're given two sides, so in this case we know NP is 15 and MP is 7, You start by using the Pythagorean theorem to find the missing side. So in this case, we're finding the missing hypotenuse. So we're going to set up 7 squared plus 15 squared is equal to the hypotenuse squared. If you compute those, that's 49 plus 225, and those add up to 274. And to get x by itself, we're going to take the square root of both sides. So we end up with about 16.6 for that hypotenuse's length. So we've found the length of NM. All right, and now we're going to use that inverse trig to find either of these angles. I'm going to find angle N. So I notice that this 7 is opposite, and then the 15 is adjacent to that angle N, telling me I'm going to have to use tangent of N is the length of the opposite over the length of the adjacent. To get that angle by itself, recall we got to use inverse tangent. So we'll take the tangent inverse of both sides. These cancel. And if you plug in tangent inverse of 7/15, you will get about 25.0 degrees. So we found angle N. Now that we know that this angle is about 25 degrees, all you have to do to get that final angle is, well, we know the triangle's angles have to add up to 180. So if we subtract 180 and that 90-degree angle at angle P and the 25 degrees that we just calculated, that will leave you with 65 degrees. All right, so there's the measure of angle M. So we've found all of our missing info. We know every single angle and every single side in this triangle, so that is solved. That's what it means to solve a right triangle. Okay, the other way that you can solve a right triangle is if you know one angle and one side. So this one's going to be a little different process. Firstly, let's list our missing info. So I notice I don't know the measure of angle T, so that's something we're going to have to find. I don't know the length of side TR, this side on the left, and I don't know the length of the hypotenuse TA. So I'm going to have to find those 3 things in this triangle. All right, so to start out, let's go ahead and find angle T. That's probably going to be the easiest place to start because I know these 3 angles have to add up to 180 degrees. So I'm going to take away the 90-degree angle at angle R. I'm going to take away the 24 degrees at angle A, and that is going to leave me with 66 degrees. So finding the measure of the missing angle is pretty easy in this case. All right, so now we can find TR. I'm going to use this angle A here, and I notice that TR is opposite angle A, and I know the side adjacent here, RA is 33. So if I am trying to find opposite, let's call that X. I can set up the tangent, because opposite over adjacent tells you to use the tangent of the angle A, is the opposite over the adjacent. And now in this case, since we know angle A is 24 degrees, we can fill that in. Okay, so this is a little review from a previous lesson. So to get this by itself, we're going to multiply both sides by 33. And if you plug 33 times tangent of 24 into a calculator, you're going to get about 14.7. So that is the length of TR. And then lastly, I'm going to use the Pythagorean theorem, the 2 legs squared, so 14.7 squared plus 33 squared is, we'll call this hypotenuse C squared. If you plug those into a calculator, you're going to get 1,305. And if you take the square root of both sides, that's going to give you about 36.1 for that last